Good morning, everybody. Welcome to 10.7. If you are in on-level geometry, this is where you're going to stop for the test. And if you're in honors, this is the second to last one that you're going to do before the test. We're in 10.7 today. Make sure you go back and rewatch the other ones. If you're having trouble with them, we will come back and do a little bit of 10.6 to start off today, because that's how these slides normally go. They start with what we did previously. So we'll do some 5-minute checks over 10.6 and see if that's still clear. So find x, assume that any segment that appears to be a tangent is a tangent. This has no tangents, but it has two secants. Remember, a secant is something that it kind of like, it'll touch the circle in exactly 2 points. So a chord is a secant. To find x, we have 85 below it and 55 on the other side. We're actually not going to use these two numbers at all. What we're going to do is take 55 and 85 and average them out. So we'll add them together, 55 and 85, add to 140. We'll divide that by 2, and we should get 70. So remember, when we have something like this, x is going to be the average of these two numbers. Find x. Once again, we're going to do the average of 90 and 160. Not 50 and 60. We're going to do 90 and 160. 90 plus 160 is 250. 250 divided by 2 is 125. Here's another problem we did in 10.7. We had a circle, and this is a arc that's from one of the sides and kind of going out. It's sort of a different look than we normally had. This one kind of has a tangent with one of the sides, but that's okay. We talked about how if it started from here and went to there and there, this would be 220 degrees. But since it's not in the middle, it's actually going to shrink down to half of what this was. So it's going to be half of that, 110. Remember, this is all in 10.7. If something about this isn't making sense, make sure you go back to the 10.7 video and see if that works. Find x. Let's actually do this one together. This is probably one of the harder kind of problems we did in 10.6. So we had something like this, and we have two secants going through. We have 110, we have a 40 degrees, and we don't know this. That's our x. So this is what we have at the moment. So this kind of angle that sort of it's all coming from, it's going through to 40, 2 to 110. Instead of taking the average, we're not going to take the average. It's not the average. What we're going to do is take 110 minus 40, and then we're going to cut that in half to be x. So instead, if it was the average, we would add this and divide by 2. It's sort of similar. We're going to subtract them and divide by 2. So this should give me 70 over 2. So x should be 35 degrees. X should be 35 degrees. So it's kind of like the average. And we look at our options. Hey, 35 is one of them. Do we have it? Yeah, exactly. That is 10.7. If you have questions about that, I would encourage you to go rewatch the videos or reach out to me and we can try to figure it out and see if there's something we can help you with. So we have a segments of a chord theorem. If two chords intersect in a circle, then the products of the lengths of the chord segments are equal. Once again, we have a circle with two chord segments. We actually did that earlier, where we had, we found those angles, but now if we want to find those, all we have to do is multiply the two pieces of them together. So let's do this one together. This is a good little example. We have a circle. We have a couple different pieces. I'll try to do every piece in a different color. That way, we have sort of a graphical representation of everything. And then let's do a green for the 8, and then an orange for the x. Okay, we don't know what x is, but we are given 12 here. We're given green as 8, and we're given this sort of maroon color as 9. All right, so we have 2 pieces of this line, 2 pieces of this line. What we're going to do is multiply 12 times 9. Then we're going to equals 8 times x. 8 times x. So 12 and 9, that's 90 plus 18, so it should be 108. I'll take my calculator and double check. 108 equals 8x divided by 8 divided by 8. And we get x equals 13.5. 13.5. Well, let's go to the thing and see what they did, and we'll see if we got something similar. Perfect. X equals 13.5. We have the same basic idea here. All we've done is we've now introduced algebraic expressions instead of numbers. Algebraic expressions instead of numbers. So let me draw a circle and we'll plot this one out. So that's x plus 4. That's x plus 2. Then up here is just x, and then x plus 10. So we have this as our problem. Make sure you're doing these on your own as well, so you can get some practice with them and make sure you are feeling good about them. So we have on one side x times x plus 10, and on the other side we have x plus 4 and then x plus 2. That's these pieces times each other and these pieces times each other. Remember, for this sort of setup, we have to FOIL them together. We have to multiply x times x first. So that's x squared, our outside, plus 2x, our inside, plus 4x. And then lastly, 4 and 2 plus 8. Smoosh the inside 2 together, and we get that. So that is our left side of our equation. The right side of our equation is a little easier. We'll just distribute that x to both. So we have x squared plus 10x. Okay, I'm going to move it down here so I have a little more room. We have x squared plus 6x plus 8. I'm just copying it down so I can have a little more room on the bottom. Right out of room on the side. That's fine. Subtract x squared on both sides, and I'm left with 6x plus 8 equals 10x. Okay, I can just solve this algebraically, and this gets us a nice number. We don't have to worry about these x squareds making it overly complicated yet. We'll divide by 4. That lets me know x should be 2. X should be 2. Before I go back to the slides, I can check this on my own. I can check this on paper. I could say, all right, this is 6, 2 and 4, and 4. Okay, and I have 2 and 12. All right, 6 times 4 gets me 24. 2 times 12, 24. Great, I know this is right, because we've checked it ourselves, we plugged it back in to see what it was. It's the same basic idea, we just have algebraic expressions as well. Multiply those together, we get this. X equals 2. So try this one on your own, pause the video, give it a shot. What you need to do is multiply x and 5 and also 10 and 8. So you have 80 equals 5x. 80 equals 5x. Divide 80 by 5 and you should get 16. Similar one to what we just did. You're going to multiply those together. Make sure you FOIL this and this. And you're going to distribute this x through here. Once you do that, you should get a number. I would plug it back in just to check. And you should get 4. So we have a new kind of problem. This is not going to use, actually it is going to use the same thing. We have a word problem though. We have biologists often examine organisms under a microscope. The circle represents the field of view under the microscope with a diameter of 2 millimeters. Determine the length of the organism if it's located 25 millimeters from the bottom field of view. Round to the nearest hundredth. Round to the nearest hundredth. All right, so we know a couple things. We know that the diameter is 2 millimeters. Okay, that is my crosshair, kind of. My organism is right here. I am told that this is 0.25 millimeters. Well, if this is 0.25 millimeters, then I know this has to be 1.75 millimeters. How do I know that? Well, if I look back at the question, it tells me my diameter is 2 millimeters. I'm given that bottom piece, so I just have to find whatever's left over to get me to 2. So because I know that, I know I have this. We also see, sorry for flipping back and forth so much. What we also know is that this guy is getting cut in half. So this side, we'll call this x, matches this side. So we know those two sides match. All right, so we have everything we need now to solve it. We have x times x is going to equal 0.25 times 1.75. This is going to give you a kind of a nasty decimal, so make sure you have your calculator available. 0.25 times 1.75, and we get 0.4375 equals x times x is not 2x. This one is going to be x squared. So how do I get rid of a squared? What I'm going to do is square root both sides. Come over here, square root. My answer, if you need the square root, it is second x squared right here. And we get a very large decimal, so we will just sort of round it. How about 3 decimal places? 661. And that is in millimeters. So let's take a look. Make sure we did this close to right. All right, so it says 2 chords of a circle are shown. You know the diameter is 2 and that the organism is 0.25. So we'll draw a model. We did that. Let x represent the unknown measure of equal lengths of the chord, which is the length of the organism. Use the products. That's what we did. Okay. So what we did is we found 1.75 because we knew it was 2 minus that. Multiply them together. Okay. Great. They did 2 decimal places where we did 3. But it should be just good enough. We could use the Pythagorean theorem. So the Pythagorean theorem, we would know this right here is 1 millimeter because that is our radius. We're told the diameter is 2, so we know our radius is 1. We can go from that corner over there, and it should work out. Yep, and it does. So Phil is installing a new window in addition for a client's home. The window is rectangular with a arch top called an eyebrow. The diagram below shows the dimensions of the window. What is the radius of the window containing the arc if the eyebrow portion of the window is not a semicircle? Okay, so hopefully you can kind of see what we're doing. What I'm going to do is draw this on our paper with what I think it wants us to do, and that way we can sort of examine it the correct way. So let me recreate it on here. And I'm actually going to change it a little bit. Let's do it this way. So we'll use the paper this way because we're going to go down a little bit. We have a window. We have an arched eyebrow, as it's called. We're told this is 2 feet, and this is 12 feet. Okay. What do we want? We want, what is the radius of the circle containing the arc? So we want to know what the radius of this circle is. What it's asking is a little bit interesting because it's kind of like this. It's kind of saying, continue this as if this circle existed. And what we're trying to find is that measurement, that radius of the circle that doesn't really exist. So we're going to treat this just like our little experiment we did with the organisms, where this is 12, and so I know this is 6, and this is 6. It's cutting it in half, but I don't know this guy. I don't know him. Why do I need that? Well, if I can figure out what the diameter is, with 2 plus whatever, I'll cut that in half to find this. Once again, if you can see the original drawing, that's not a semicircle. It's what it says in the last line. What is the radius of the circle containing the arc if the eyebrow portion is not a semicircle? Okay, so what we're going to do is scoot down a little bit. Actually, I'll try to keep everything in frame. 6 times 6 equals 2 times x. We'll call this x. We don't have that. 36 is 2x. So x should be 18 feet. 18 feet. Which means, let's change colors because we're kind of changing what we're talking about. If x is 18 feet, the diameter is 2 feet plus 18 feet. So that's 20 feet. So our radius is going to be 10 feet. So it's not exactly like this. It's a smaller circle. I just drew the arc a little bigger, but that's okay. It was mainly for me to visualize what's going on in my head and see everything. Hopefully you can see kind of what we were doing. Let's go back to the picture. We have 10 feet, 20 feet, 36 feet, and 18 feet. And the answer is 10 feet. All right, this is one of our final properties we're going to talk about today, the secant segments theorem. If two secants intersect in the exterior of a circle, then the product of the measures of one secant segment are going to be equal to the product of the measures of the other secant segment, and the both those put together. Hopefully that makes some kind of sense. If not, let's kind of reframe it. What it's saying is on a circle where you have two secants, let's go to the zoom in cam. What it's saying is outside times whole equals outside times whole. Once again, It's saying outside times whole equals outside times whole. Not whole, but all of it. That's the main idea of this one. So let's do some practice problems. I think it'll make more sense when we do this. Perfect. This is a great problem. It's very straightforward, and hopefully we don't get lost in it. So we have a circle. We have two secants coming through. We'll talk about what happens if we have a secant and a tangent, but it's not going to be too different. We have 8 over here, x over here, 10 over here, and 24 right here. And if you notice, 24 is from here to here. 10 is from here to here, 8 is from here to here, and this is x. To find x, remember our formula. This isn't the mathy way to write it, but our formula, outside times whole equals outside times whole. What we have is something like this. Outside times whole. And what's the whole? The whole is 8 plus whatever x is. Equals, we'll change colors for this side. So we'll make this our red side so we can follow along. And this be our blue side. Equals outside times whole. What's whole? 10 plus 24. That's 34. Remember, 10 plus 24. Let me distribute in here. So I get a new red side. That's 64 plus 8x equals 340. Okay. Hopefully that makes sense how we got there so far. Now all I have to do is solve this problem. Minus 64, minus 64. So 340 minus 64, 276 is 8x. Divide 8 by that. Divided by 8, I get x equaling 34.5. Once again, the main idea about this, the thing that you should make sure you have down on your paper is this. Outside times whole equals outside times whole. Let's look back at the notes and see if we got that one right. Okay. That's what we had. 34.5. Perfect. 34.5. You can see how we did that. We had those two pieces multiplied together, solve the problem. So try this one on your own. Pause the video. You're going to multiply outside times whole. So 25 times 25 and 27 put together equals x times 24 plus x. And you should end up getting 26. 26. So this is the theorem 10.1.7. And then we have a tangent and a secant. A tangent and a secant. If they intersect at the exterior of a circle, then the square of the measure of the tangent is equal to the product of the measures of the secant and its external secant segment. Okay, that's a lot of words. Let's just jump to an example because I think this is, it could be very overwhelming. So an example is this. This is our example. Let's copy this down and we'll do it together. So we have a secant on this side, and this side we have a tangent. We know this is x, we know this is x plus 2, and this is 12. So, let's imagine this is all we had to work with. We did not have the slide before, so we knew nothing about this. One thing we can do, one thing we can still use, is this. This is still a good formula. I know you're saying, but Mr. Goodrow, these are two secants, and this one's a secant and a tangent, but it is still applicable. This is why I chose these words, because we can still do this. So let's try this with this setup. So outside times whole of this one is outside, is x, times whole, x plus 2. Okay. Outside plus outside times whole. And then over here we have the outside. Well, we're not in the circle, so I guess our outside is 12 times the whole. Well, the whole thing is just 12. So let's look at what we just did. What we just did is this. We said, since our tangent is outside and the whole thing, we're just going to do it twice. Because j to k is all outside the circle, and it's also the whole line. So we can do outside times whole to get jk squared. And now we can solve this. 144 on this side. This becomes 2x plus 2. Distribute x to both of those. That's 2x squared plus 2x equals 144. This is going to require a little more complex math solving. This is a harder problem than you will have on a quiz or test. So let's say remember, because we are confined to doing this online, we can't go into the nuance of this and take days to kind of learn about this, how to solve these kind of problems. Maybe you remember how to do this kind of stuff, where we have maybe 2x squared plus 2x. Let's move the 144 across. Equals 0. Once again, make sure you get that down. Yours would be much simpler. They may just be maybe a number here and then x plus 2 over here. You can try that if you would like. So we could do something like divide by 2. Divide by 2. That doesn't affect that side. X squared plus x minus 144 cut in half is going to be negative 72 equals 0. Okay, negative 72 equals 0. If you remember your factoring from long ago, that's going to break off into x plus 9 and then x minus 8 equals 0. So x is going to equal negative 9 or x equals 8. It can't be a negative number, so we don't want that. So x is going to equal 8. Once again, I cannot stress this enough. You will not have any of this on your tests and quizzes while we are separated over the internet, just because it's a little too difficult for me to do this kind of part. So let's do another example with this idea that's not going to be like this. Once again, you're not going to have factoring on this. That's what this one's talking about. You can see that we get there. Perfect. Let's do this one together. This one looks like this is a better problem for what you should expect on something. We have a circle. We have a secant over here and a tangent here. Our tangent's x. This is 20 and 25. All right, so we have outside times whole. 20 times the whole is 45 equals outside times whole. 20 times 45 is going to be a big number, exactly 900. What I need to do to find what x is take the square root of both sides. So I get square root of 900. X should be 30. Once again, this is the kind of problem you should be thinking about, where this part is not as complex, there's no factoring. But this idea is still there, because it's something I can test you where you go outside and whole, outside and whole. So let's see what our options are. Our options are 22, 36, 25, 28, and 30. And we have 30. So that is 10, what was that, 7? Yes, that is 10-7. I hope you find that of some help. But if not, please go back, rewatch it. There's some things that might be a little difficult, but I hope you start to see the patterns in what we're doing and how you do sort of the same things even with a couple different kinds of circles. We have outside times whole, outside times whole. That was one of our big highlights. That, and also the multiplying the two legs by each other. That was what we're going to do. One dealt with two secants, the other one's dealt with other pieces. All right, well, if you have any questions, please don't hesitate to reach out, and I will do my best to answer them. But until then, I will see you guys later.